All right, let's go to the emails. I'll pull this question up later. I want to get to the other emails first. I'm gonna take that question out as I get to it. This is 1.1, question 100 in the book, question number 26. I think this is the question we were talking about. No, this is a question where we already went over it. We went over this Tuesday. Let's go ahead and do it again because we have a few people that wasn't here. So, or whatever day this is, I don't know what day it is. Monday. We went over it Monday. So
we went over this one yesterday, actually.
Yeah, that's what we did the same. This is the same one.
Okay.
Okay, it's the same one. I thought the numbers were different.
Oh, the numbers are different. Wait, no, this is, yeah, 20.
Is it the same one? Somebody look in your notes.
Yeah, we already did this one.
Yes, okay, we already did this one. All right, I'll take that one out. That one's delete. Okay, this is 1.1, number 14, number 7. 1.1, number 14, number 7. This is a test question. This is a good question. As long as they don't screw it up. I hope they don't screw it up. F of x is equal to the cube root of x.
We did these two.
Did this too.
Yeah. Oh, we did this one also? Mm-hmm. Okay, I'm sorry. I did so many yesterday. I did 4 or 5. I can't remember what I did. I'm sorry. It's the drugs and the alcohol. I need to quit drinking out of this cup. Got to wash it every now and then. All right, 1.166/21. Let me just ask y'all, did we do this one? I don't think we did. But this one is a test question. Anything having to do with the difference quotient, anything having to do with completing the square is a test question. So let's do this one. I'm going to rewrite this right here in blue. And that's going to give me 6 parentheses squared minus 7 times parentheses plus 1. And that's going to represent f times x plus h. And then I'm going to subtract, and then I'm going to do in red, I'm just going to rewrite f of x, and that's going to be 6x squared minus 7x plus 1. All that over what? H. Now what are we going to plug into the parentheses on f of x plus h?
X plus h.
X plus h. And now you're going to depend on your algebra. So go ahead and knock that out, because the rest of the problem is algebra. So that's going to give us 6 times x squared plus 2xh plus h squared, that is our shortcut number 1, minus 7x minus 7h plus 1 minus 6x squared plus 7x minus 1. 6x squared plus 12xh plus 6h squared minus 7x minus 7h plus 1 minus 6x squared plus 7x minus 1 all over. Take our red pen out. And what happens to the 6x squareds?
They're going to cancel out.
They're going to cancel. 7x should cancel. And the 1's cancel. And you should be left with all h terms. Most of the time, that's what's going to happen. That's going to give you 12xh plus 6h squared minus 7h over h. And whether you cancel with it being in the denominator, or you factor out a h, that's going to give you 12x plus 6h minus 7. Now remember, that is the answer for right now. After we get through with the limit theory, we're going to apply the limit as h approaches 0, and that's going to give us 12x minus 7, which is the derivative of 6x squared minus 7x plus 1. But we got to crawl before we can walk, and we got to finish this algebra review, which we're going to finish Friday.
The a squared, the x and a formula to get the derivative. I forget exactly. It's the one that uses x and a. Look at
The power rule. You talking about the power rule? Yeah, the quotient rule.
Okay.
I mean, the difference quotient.
Is that just a different way to write the difference?
That's the long way. Yeah. Well, the whole purpose of us doing this, basically, is so you appreciate the calculus, because the calculus is basically taking the limit theory and the difference quotient, and the calculus is doing the power rule instead of doing all that work.
Okay.
That's why we actually do it. All right, so whoever sent that question, does that help you out? Who's got a question? Everybody good? Okay, next question. That was a good test question. So let me delete that one. 1.188/25, I think that's that question that we are not going to talk about. Hey, I see how to get f of g of -1 in it, but when he gets, I think that one and this one, there's about 3 of those that I can get. But the problem is, there is no way in Hades that you will get them unless somebody tells you blatantly how to do it. And to me, that's not a good question. So that's why I took it out. No coughing in class. All right, so that's 25. Okay, this is 1.2, 47/14. Is this a test question? It could be. It could be a test question. I usually, well, let me get rid of this. Let me blow it up a little bit. All right, go ahead and sketch that graph out in your notes. This is a piecewise function, basically. Okay, determine the slope of the function on the right. So there's 2 slopes, right? There's a slope on the left, and there's a slope what? On the right. You can't say that there's one slope, because that's like saying an apple and orange is equal to an orange. So you're going to have to calculate 2 slopes, and I guess that's what they're asking here, what the slope is. I'm just going to calculate the 2 slopes, and then you type it in however you need to. All right, so the first one, you're going to pick 2 points. Now, of course, I'm going to pick the x and y intercept, because that's the easiest thing to pick, if you can. So we'll call this one slope number 1. We'll paint it blue. Give me a second. All right, there's slope number 1. And then number 2. And I'm assuming that they want you to do 2 separate slopes, because that's the only way technically you can do it. But okay, my blue disappeared. I don't know why my blue disappeared. There we go. All right, so you got 2 slopes. I'll do the first one in blue. I'm going to pick this intercept right here and this intercept right here. So the x-intercept, 0 for y, so that's going to be -3, 0 and -3, right? I'm sorry, -3 and 0. Sorry. -3 and 0. And my y-intercept is what? 0, -3. We read from left to right, so that's going to be x of 1, y sub 1, x of 2, y sub 2.
Isn't y sub 2 just positive 3?
Thank you. I don't know why I just did that, my bad. Y sub 2 minus y sub 1 over x of 2 minus x of 1. Y sub 2 is 3 minus 0 over 0 minus a -3. And that's going to be 3 over what?
3.
So that's your slope for your blue line. Now, a lot of people say, well, Hubert, that's easy. Well, I'm going to tell you something. If I give you 10, if 10 people took this problem, I'd get 3 people and they'd get it wrong. Somebody tell me why.
Looking
The
from
2
left to
negatives right here. Because there's some people that don't need the parentheses because they invented mathematics. And that right there will get you. Okay, now let's do the red.
So you can look at that.
Huh?
So even though you can look at that and see it's not a -1.
I know that, but when you're calculating it, what I'm saying is when you're calculating it, some people will screw that up. All right, but that's a good point. All right, here we got the same points, 3 and 0, 0 and 3. That's your y-intercept. 0, 3. And then what's your x? We don't have an x, but I'm going to pick this point right here. 3 and 2. Three and 2, x of 1, y sub 1, x of 2, y sub 2. M is equal to parentheses minus parentheses over parentheses minus parentheses. Y sub 2 is 2, 3 and 0. 2 minus 3 is what? -1 over 3. So that should be your answers. Did anybody, somebody have this question? Is that the answers that they're wanting? I would assume it is. So it looks like when x is less than 0, we've got 1. So we'll take our heavy duty cursor and put 1 right there. And then here we will put negative, and then negative. And a lot of times they want you to put the negative in front of the fraction. So I'm going to put a 1 and a 3 right here. And I feel good about myself. I don't have to put smokestacks on my pickup truck. Everybody good? Yeah, Hubert. Settle down, Pendleton. That's a okay test question, but I would much rather you be able to do the quotient, the difference quotient. And I mean, that's good. That's a good review question for homework, but it's a review. It's kind of too basic for the test. I would much rather put completing the square, rationalizing the denominator, or factoring on there. But good question. Next one, 1.281/22. Imagine a lidless box. Oh my Lord, I hate when they do this imagine stuff. With a lidless box with height h and a square base whose blah 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 the box must have. Okay, first of all, draw yourself a picture. So you know you got a box that looks something like this. You know that the bottom is a square. So we're just going to say side, 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 side. And we know that it's I'm not an artist, okay? So, there we go. And we know that this, let me fill in the gaps here with some silicone. There we go. All right. Some of y'all have no idea what silicone is, but you will eventually. All right, height is this way and length is this way. So I'm going to just draw to help y'all out because that's what I'm here for. That's a length like that. Okay, and remember that the sides are the same. Side, might as well just go ahead and call that side. The only thing difference is the what? The height. The height is the only thing that's different. Does everybody see the relationship between the sides and the length, that they're going to be the same? You'd see it better if I was a better artist, but the height is going to be different. So basically, what is volume? Length times width times what? And what is area? Okay. So we know that the 127 goes right here. And we know that the length and the width is the same, right? So that would be like s squared, right? And then times the height. Now it looks like to me that since we know the height is the only thing that we don't know, we're going to solve for height. So h is equal to 127 over what? S squared. Now, I think I know where this is going. So I think you're going to end up, A is equal to base times height. And then you're going to take this and plug it in for what? Height, I think. So that's A is equal to base times 127 over S squared. That's going to be B squared, right? Sorry. I'm killing two birds with one stone. I think that's where they're going with this. Anybody did the problem? Is that where they're going with it?
I know it's C.
No, yeah. Well, yeah. And that's where this comes from right here, the 127. Yeah. So you could take
where did you change S squared to B squared?
Because S is B right here. See? S, it says it's a square. So the bases are all the what? All the same. This is a square. Right here. So you could have said base times height right here. So you could have said base times height. You could have done that. Base squared divided by base squared. Could have done that. And I think that's where that one's going with that one. Says find the graph that gives the surface area of the box. That's where it's going, where I did the A is equal to base times the height. So that's where that's going. And basically, you see that it's going to turn into, because you got, how many heights are there? 4? What's 4 times 127? Should be 508.
Yes, sir. So how do you get the single x on the bottom instead of the x squared?
Well, what's b squared divided by, what's b, what happens to these b's?
Oh, yeah.
See? You'd see how it works. It's going to work out. Do a couple of more transition. This B cancels, you get 127 over B. And that's where you get 127 over B right here, 127 times 4. You got 4 of them, okay, because you got to have 4 surfaces, okay? So 4 times 127 is 508 over X. So it's pretty simple. Huh?
I forgot it said surface area.
Yeah, it's surface area. That's where that comes from, right here. Surface area means that you've got to get this surface right here. You've got to get this surface. There's 4 surface areas along with the 5th one. And that's going to be your length times width. But anyway, good homework question. Test question, I wouldn't put it on test because to me, that is not what we're dealing with for calculus, okay? What we're dealing with in calculus is the mechanics of the algebra, okay? This is a nice question to have, but it's not a test question, okay? Work with it. If you still have a question for it, send it to me and I'll do it. I'll keep going, okay? All right, let's go to another one. 1.285 / I'm trying to get to all these questions before 4 o'clock, and I know I'm pushed today, but just work with me. Test question. What the heck are y'all talking about factorials for in this? This ain't 120. This is not a good homework question or a test question. Factorial. What is factorial? Multiplying by the sequence. Factorial, 2 factorial is equal to 2 times 1. 3 factorial is equal to 3 times 2 times 1. 4 factorial is equal to 4 times 3 times 2 times 1. You just need to know the definition of a factorial to do this problem.
Isn't like a natural exponential growth?
Well, there's a pattern to it, but the pattern is you just multiply by the previous. 4 times 3 factorial equals 4 factorial. 5 times 4 factorial equal to 5 factorial. So there's a pattern to it, but what they're wanting you to do right here is 1 factorial is 1. 1 factorial is equal to 1 times, that's it, it's 1. So that's 1. 2 factorial is what? 2. 3 factorial is what? 6. This is not a good question.
Is this going to be relevant later on?
No.
Okay.
Now you're going to see harmonic functions with sequences. You're going to see that in Calc 3. This is not relevant to what we're doing now. 4 is what? 4 times 6 is 24. And 5 will be 5 times 24, which is what?
120.
108. What? What is it?
120, I think.
120. Okay. And they want you to know when, 10 factorial is going to give you a BA number close to 10 to the 6th, I believe. What's 10 factorial? Well, 10 factorial is going to be 10 times 9 times 8 times 7 times 6 times 4 times 3 times 2 and times 1, but 1 don't matter. 10 times 9 is 90. 90 times 8 is 720. 720 times 7 is 40, is 5040. 50, somebody do 10 factorial in your calculator for me.
I know it's a 6.
It's a BA number.
It's an H digit number.
Yeah. Somebody, what's 10 factorial? You got your calculators?
3628800.
362, what?
8800.
I think that will take care of your 10 to the 6th power. Oops, 3 million. I think I moved to. There you go. 3,628,800. this one, the only reason I'm not taking this one out is because it's so simple. This has nothing to do with your first unit. The second, it really doesn't have anything to do. It might have to do with harmonic functions. If we get into harmonic functions, maybe in unit 3, maybe. Somebody look at your outline and see if we get into harmonic functions, but there's no reason for this question. No reason at all. What's 10 to the 6th power? It's going to be a BA number 2, but I think this one's a little bit more. It's 5 zeros. Yeah. 5 or 6 zeros, yeah. All right, anyway, that's how you do that question, and it's not a stupid question because y'all don't send stupid questions, but it's a question that's irrelevant to what we're doing. I mean, the question that I gave you credit for has more relevance than this one. I think that might be a mistake. I need to tell the person about that who's in charge of this class. I don't think that's a good question. Next question. 1.3, 1.3, number 3, number 2. Okay, determine which graph is a one-to-one. Well, the vertical line tells us it's a function. What does the horizontal line tell us? The horizontal line test tells us if it's one-to-one, right? You're supposed to say yes or no. Yes. Vertical line test tells if a function is a function. Y'all remember that? So if I have a hyperbola and I draw a vertical line through it, is a hyperbola a function? No. The horizontal line test tells if it's one-to-one. Okay? Now, the trick with this one is that it's asking you from here to here, but not here to here. Well, the key is this one. Which one is not from negative infinity to positive infinity? Well, this one and this one. I don't know what the C looks like. Let me see what C looks like. Well, if it'll let me. Yeah, C could be 1. D is not the answer. Why is D not the answer? Because that is a one-to-one. So that's not it. So it's either, I think it's going to either be A or B. Because we haven't even got to that yet. So A or B, I'm going to focus on A or B because I think it's going to be one of those two. Now let's read. I'm trying to do two things at one time. Y'all bear with me a second. And it's not cooperating. There we go. Okay. Now, let's find negative 3. We've done this. Now let's find negative 3. Negative 3. 1, 2, 3. So that means that function right there. And then this one is negative 3. 1, 2, 3. Negative 3 right there. Which one is a one-to-one function? Huh? A.
There's a one-to-one function I have to follow on
It has to hit one time.
the vertex then.
No, the horizontal line test.
Oh, I'm sorry, I see what you're saying now.
It could even be like.
See, this one,
I got you.
this one hits what?
Yeah, twice.
Twice. You can do it anywhere on the.
Well, so it does have to be the vertex then.
It has to be. You have to check the whole line.
Right.
I mean the whole function.
Well, and
If it's
you
not on the
could do.
vertex, then you would have it at 2
Well,
points.
think about A. You could do like negative 4, and it would still be.
Yeah.
Yeah. So it has to be on.
It has to be A. So that one you could use, but pretty much deduction. So A is your answer. Remember, Horizontal line test checks to see if it's 1-to-1. If you have one intersection, it is a 1-to-1. If you have two intersections, this one right here had 2 right there, then it is not a 1-to-1. That could be a test question, but I wouldn't do this one. There's a homework question that somebody sent. It's a good test question. I'll show you that in just a second. Let me see if I can find it. It might be this one. This is this one. That's the question I would put on the test. I would just ask you, is this a 1-to-1 function? And you would say what? No. But they're not asking you for one interval. They're asking you for how many? 3 intervals. Okay? So you got to find there's the max, and this is the what? Min. That's also your not your inflection points, but it's your transition points between increasing and decreasing values. So you've got 3 increments. You've got this increment.
So we are still going over relative maximum.
Yeah, well, yeah, we went over that with, yeah. There's one, and then I'll do the last one in green. And all you have to do, now, are these inclusive? They cannot be inclusive because they can't be the same what? Point. So you've got 3 points. The first one is negative infinity to, let me do that in blue. Negative infinity to what? -1. Non-inclusive. And then from red, -1, non-inclusive, to +1, non-inclusive. And then verde, from 1 to what? Infinity.
It says it's inclusive up there. Is that a mistake?
It's got brackets.
I don't know how it can be inclusive if you're talking about, okay, if you're, okay, for 1-to-1, I guess, I disagree with that because if you use that 1 point, okay, 1 point, yeah, it's still one intersection. You could make it inclusive. I'm thinking of increasing and decreasing values, I'm sorry. So you could do there and red here and here and green here. Now, if I gave you that on the test question, it would be, is this a 1-to-1 function? And of course you would say no, but they're asking you in increments. Okay, next question. There are some questions on this book I like and some I don't like, so you're just going to have to bear with me. Okay, I'm going to delete that one. This is AR3. What's AR?
Those are the old ones. We already went through those
Okay.
at the end of last class.
Oh, okay. What's AR though?
As for review.
Oh, okay. Oh, those are the ones I picked. Okay, good. All right, so what we'll do is we'll go ahead and it's 6 till. We'll go ahead and quit for today. The only thing y'all need to work on now is 1.4, and I haven't covered it yet. I started it, and we'll work on 1.4 tomorrow. Okay, if you want to go ahead and try some of the homework on 1.3 and 1.4, 10 questions, and I'm going to get to 1.4 tomorrow. I'll cover that tomorrow. Let me go call the roll and set off the recorder.